Hey, welcome back. Good to see you again. Thanks for joining the channel. It's another Monday, and for start of a new week, we have another project to start on. This is the JVC AX-9 integrated amplifier. This one is the big brother to the JVC AX-7 that I did a number of episodes back. Now, the owner of this amplifier watched my AX-7 video, and he figured, well, I need to get mine in for service because it's got some problems. And yeah, it does have problems. The owner of this one drove through a snowstorm 8 hours and on New Year's Eve, or sorry, yeah, it was New Year's Eve, and dropped it off just so that he could get it repaired, and he jumped through some hoops to get it here. But it's sat for, what is today, the 26th or 25th of January, so it sat here for nearly a month waiting for the bench, so it's time to get working on this. Now, I had a chance to hook this up yesterday and listen to it for a couple hours. This is a great sounding amplifier. I really like this. This reminds me of the AX7 when I listened to it after I was done. It sounded fantastic, and this one's the same thing. This one's you got more power. I don't know what the power specs are on it. I don't know any of the specs. I typically don't look up specs on anything I work on. Maybe I do after, but I really don't care what the specs are. It just got to get it working again. But this one has problems, and right away, as soon as I plugged it in, I found the first problem. The power switch is broken. Even though it latches here, it's continuously on, so you can't shut it off with the power switch. So we're going to have to replace the switch. It doesn't feel right either. It's kind of mushy in there. So something's wrong with that, definitely. Another thing is lamps. It only has like 1 or 2 working lamps left. All the rest of them are burned out. And if we look down here, there's this strip. It's kind of a mirrored finish on it. And it is, it's got some etching through the coating and with text, and each one of these should have a lamp behind it, and there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. I think there should be 12 lamps behind here, but we only have like 2 of them working. So we're going to have to do something with that. We're going to, Phono stage has no left channel. It's completely dead. So we only have audio coming out through the right, which is a bummer. Now when I put it on left, this, and I crank this to the left so it's silent when you're listening to a record, and then when you turn this up, you can hear bleed through from the right channel, but I don't think the left is working at all. To tell you the truth, I think the stage is completely dead. Okay, the front door. This door does not stay shut, so we're going to have to figure out a solution for this. There is a spring feel to it when you get up here, but it's not strong enough to hold this door up. This door is aluminum plate, and it's quite heavy. So we're going to have to figure out a solution for this, because it should be shut when you want it shut and when you want to open it. Okay. Last thing, it's a minor thing. The treble pot is quite scratchy, so we'll get in there when we do that. Bass and balance are okay, but the treble pot was quite scratchy. And the switches seemed okay. I didn't have any issues with any of the switches, and I tried manipulating them, no dropouts. Everything seems fine that way. Here's a look at some of the front panel controls. The power switch on the left. We have 2 speaker switches, 1 and 2. We have headphones output, subsonic filter, and our tone defeat switch, which is, we push it in to activate the tone controls, which is kind of opposite what we're used to. When it's out, the tone controls are off, and it's a straight line through. We have tape monitor 2 on the front panel, and we can select over here. We can select our tape monitor 2 from the front or the back with this switch, because there's another set of RCAs on the back for this. Balance control. We have our tape switches here, tape monitor 1 and 2. The tape monitor switch up here, our main tape monitor switch, but then this one here selects tape monitor 1 or 2, and then front or back. So you can actually hook up 3 decks instead of just 2. And then we have our dubbing switches and record. You can shut it off. And then we have our phono. We have two phono inputs, 1 and 2, and we select it with this switch. And then we can select between moving coil, moving magnet. And this is our phono up here. Tuner, auxiliary, tape monitor, these are our main. And then we can select turntable down there. Volume control, obviously. And the muting, which gives you minus 20 dB, I believe. On the back, you got 3 courtesy outlets here on the right. Model plate. This plate here is a blanking plate. I think we might have a voltage selector behind here. Probably not on this model, but maybe some other models might have it. Fuse, what does it say? 6 amp. Let's try this. See what they got for a fuse in here. Come on. Six amp fuse, that's great. 2 speaker outputs. And then here we have our inputs. We got 2 phono inputs with 2 grounds. We have moving magnet cartridge load in ohms. So we got 100 ohms, 47 kilo ohms, 100K. Is that right? I've never seen 100 ohm. And if it is, that's really weird. Okay. Inputs for tuner and auxiliary. This is tape loop 2, tape loop 1 with a DIN connector for tape loop 1. There's no breakouts for pre or main amplifiers, which is kind of unfortunate. An amplifier like this, you'd want to have that, I think, but it's not available on this one. Okay, I can't get my camera back far enough to get it all in frame. This thing's a big beast. And it's heavy too, so let's take the cover off. And the cover looks good on the inside, nice and clean. You can tell it wasn't the smoker's delight. But look at this thing. You just got wow inside. That's all it is, wow. And it does sound good. Like, I listened to this for a couple hours and I was really impressed. So we got a lot going on here. This is all power amplifier here. We have a protection circuit here in the back with relays. Kind of a daughter card here with probably drivers on it, who knows. Or maybe they have voltage amplification input section on this card, I'm not sure. So a couple nice heat sinks, great toroidal transformer here. It's all covered with a metal shield. I bet you the capacitors are back here. And we have this here out front is a metal shield as well. It's covering some that's probably all our tone circuits and stuff on behind here. Back here on this side looks like we have phono stage right next to the inputs, and I can already see caps here are cooked. Caps are cooked everywhere. Here, let me show you a little example of what I saw. You can see some of these are discolored here. This one here especially, it's turned gray. It should be a green like this, but these ones are turning gray because they heat soaked. And back here, this is power supply back here, and you can see these caps, the heat shrinking is pulled back and cooked a lot of these. So for whatever reason we lost one channel in this amplifier board, so I'll have to go through and check everything out. Some of these transistors look big too. So this will be a fun project. So this is going to be one of those examples where we're going to go through and change all the capacitors, and it's going to sound exactly the same after from when we started, because the way they designed some of these circuits, they don't rely on capacitors for capacitor coupling or you know. And then this is the power supply side. You pull some covers off. It's very nicely built. We've got a shield here covering all the inputs and outputs. Shield here for tone circuits. Shielding for the power supply. The only thing that doesn't have shielding is a power amplifier, but that needs full air circulation. This is a nice rig. So somebody's replaced these binding posts for the speaker outputs. And if I look on the back here, you can see why. came to that conclusion. I don't know if I wouldn't really call it a butcher job, but it doesn't look the greatest. We're going to take this all apart and make sure it's all good. I could have done a neater job. I don't know if you can see that. Let me try turning this. I don't know, some of these might look like they might be cracked, but I didn't notice any dropouts when I listened to it, so I don't think there's any cracks here. Same with the relays. I didn't get any indication that the relays were dirty. It just worked, and it worked well. Here's a look behind this shield. And we have quite a bit of stuff going on here. This looks like all tone board back here. It's got its own power supplies. There's boards underneath. I don't know what they're doing with those. Some switching boards here. An Alps potentiometer. This Alps potentiometer looks pretty nice. Here's the cover for the power supply. And that really shows you nothing at all. It's the capacitors underneath here. I can see a board on this side. I think the caps are, there's 4 caps it looks like. And it does have a input power selector. It's just hidden by that blanking plate. You can see it here on the board. I got it unplugged now so I can poke in here. You can see it on the board. So if I pulled this cover off, you'd see the plate, how to adjust it. And this is says it's set up for 120 volts. So I'll pull this plate off and check and make sure it's 120, just to make sure. Here's our power switch. It doesn't work. We have it. Looks like we have another set of contacts here that's not being used. We can maybe utilize those, or we could replace the switch. Choice is ours. More power supply caps. These ones don't look as baked as the other ones do. Yeah, this will be a good project. I think I like this. This is going to be fun. Fun for me, anyways. Might not be fun for some techs, but I really enjoyed ripping everything apart, cleaning, and putting it all back together again, and then listening to it. I like this. It's a very modular design. Things plug into each other. Yeah. It's not like the Sensuis and Marantzas I've been working on lately. They're really difficult to work on because they use wire wraps and they don't use connectors. They just hardwire everything. And this thing here, these master sheet caps are not leaking yet, which is, oh yes, they are. You can see this one's leaking. And we do have cracked solders on this, I'm pretty sure. I can see some already. Yeah, this will be a good project for sure. Yeah, so this is amplifier circuits here, power amplifiers for both channels. Don't see a lot of capacitors in here, do you? That's why it sounded so great when I was listening to it. This is all DC coupled servo circuits here. So a lot of this does not rely on electrolytics for passing sound from one stage to the other. That's why it continues to sound good even though all the caps are baked in it. Two screws, alright. Alright. Yeah, wow, look at the caps under here. These are 4700s at 71 volts. We got more stuff here that's been, that doesn't look good. I don't know what that's all about. Okay, so we got the underside of the power amplifier. We got all our power devices here and here. This is all the card connectors for the other board, and I can see right now a lot of solder joints need to be touched up for sure. They've done some rework to this board. Somebody's done some rework to it. Don't know what the hell they're doing here. Somebody's been Let me show you. Somebody's been etching at the board with a, I don't know if you can see this, but somebody's been gouging the board out. They must have been chasing a bridge solder joint or something. Somebody really went to town on this. And cut traces. I don't know what is going on with this. They wouldn't have done that at the factory. Can you see any of that? The whole board is like that. It's got these deep etches into the phenolic. You can see them everywhere. Here, 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 here. All throughout here. All. Somebody's worked on this and spent a lot of time doing things. And then there's this. I don't know what this is about. Got some copper missing, some copper foil missing, and then some solder. Maybe they were tacking wires on here. That's weird as well. Okay, here's the front panel. This is quite a heavy unit. It's just a big chunk of aluminum built up. This is cast. The ends are cast. Got your volume pot here in the center. That can be removed with the, what's this, grease? Somebody put grease in there. I don't know, this is weird. There's a lot of weird things I'm seeing. These are all our lamps under here, and I counted 12 of them. Somebody's been working on these before. Looks like they tried replacing some of them, and they're not. Doesn't look like they're very successful or not. So this is prime candidate for LEDs in here. And we have glue that's dying, and the switches are falling out. Here's a switch that fell out. So I expect there's some more that are loose. I might have to re-glue a lot of this. And as far as the door goes, we have a dampening device on this end with a piston. It's supposed to be viscous fluid in there, but I think it's all leaked out or evaporated or something. It's not viscosity anymore. And on this side, we have our device. There's a little brass or copper spring in there. I don't know if you can see it, and that is to stop the door from flopping open on its own. So we just need to tighten this spring a little bit, or that plastic actually has bent over time and just kind of caved in. So maybe we can prop that plastic out a bit to give it a better feel and to hold it better. So we'll get started on this after. Put this aside. This looks like the tone board here. There's quite a bit of heat damage, especially right here, right? This transistor, all the pads have lifted. Looks like they've lifted. Yeah, they have. So we'll have to deal with that. Interesting. I like the modular construction of this, the connectors. This will make servicing a lot easier. So here's a look at the Phono amplifier equalizer out of the unit. It comes out as a module. We remove two connectors here. This plugs into the back panel, and yeah, everything's very nicely laid out. So left channel is dead on this. I don't know which is left channel. We'll figure that out. I'm guessing it's going to be a dead transistor or a open resistor, fuse resistor. Dead caps won't cause a channel to go dead like that. It'll cause it to go distorted or weak. But you can see some of the caps in this thing. This one's cooked. This one's cooked. All of these ones back here are cooked. This one's cooked for sure. These three. And the conductive glue here. Although I don't see any corrosion around the glue. Actually, that glue is not corrosive. It's just burnt looking from all the heat. So whatever reason our left channel is dead, I'm going to have to figure out which side is our left channel, and then I'm going to start probably doing diode checks on all these transistors to see if I have a shorted transistor or open transistor. And if I can't find anything there, I'll check all these resistors just to make sure I don't have an open resistor somewhere, fuse resistor. Got some 2SK 150 here. This is like a FET, double FET, dual FET. And then we got some dual FETs here. They're called L FETs. And then JVC branded. They might be just regular FETs with an aluminum cap on top. That's what they are. But they're probably matched. So, and then lots and lots of transistors. You got 2SC 458s, but these are the upgraded ones that don't fail. The 2SC set 1775s, I've seen a lot of those fail. 2SC 2546. There's lots of different transistors on this thing. So the power amp comes out as a module. You just remove 3 screws in the front, 2 in the back, and then remove the screws for the speaker connector on the back panel. That comes out with it. 1 connector, 2 connectors, 3 connectors, and I think this connector here too. I had to desolder 4 wires from the board, and then it's all separated, completely separate now. I can take this out, service it, clean it, and I just labeled the wires. The board is labeled with numbers, so you just corresponding wire. Pretty simple. So this is all that's connecting it. And then what you're left with is pretty much a bare chassis with just the power supply left. It's starting to get a lot lighter now. Now I can get access to these caps. I can pull this board out and I can start testing these caps. Some of these might get replaced depending on their condition. Don't know yet. Haven't made that determination. But yeah. It's a nice design. It's got like, I think this is a inrush current limiter or a soft start circuit. It's got a relay here and a resistor. I don't know what value it is. And this is a power supply board with fusing, and I think this is mains wiring, to tell you the truth. I'm not sure. I'll dig into it. Alright, so here's that first card I pulled out. This one has dual duty. This one has a protection circuit on the left hand side. So this is all monitoring the power amplifiers. I think this TA7317P chip is a protection chip. And then on this side we have bias current, right? So this is adjusting bias current for both channels, idling left, idling right, and this takes care of the biasing circuits. And they put it on a daughter card for some reason, I don't know why. But there's a couple caps here. Let's go through these together. These, this one's a 22 and a 47. So let's see what we got here. So the 22 is going to measure 19. That's down in value. It's not good. The 47 is going to measure 43. Actually, those two aren't bad. This one here is another 47. This one measures down around 38. This is a 470 nanofarad cap here. So half a microfarad, and we get bang on. And this last one here is the 22 at 16 volts. This one's down to 15, so that cap's dead. So yeah, a lot of these are dying, and I'm going to replace them all. So I'll get started on that. And then on the back side, I did check all these resistors already, all these blue ones, they're all fine. And then I just need to go over, clean the board, and check for cracked solders. And that'll be it for this one, and then move on to the next. Alright, here's a look at the finished Phono stage board. Now all of these caps were gone, they were dead. There's right here, this is all power supply section on this side. Let's have a look at the schematic a bit. So signal comes in, there's some switching here for between Phono 1, Phono 2, moving magnet, moving coil, that kind of stuff. And then it goes through differential pair with FETs. And it goes through here, signal's going through. You see the dark line where the signal goes, and then it goes through. It goes like a little amplifier, actually. It is an amplifier, and then it has an output stage here with some power, medium power devices. So signal goes through, everything, and then our signal comes out here. This is all power supply here on this side. And these 6 caps, these are 100 microfarad at 100 volts. There's 6 of them. And 3 on the negative, 3 on the positive. That's where these were here. And they were all dead, every one of them. Some measured like 90 picofarads, that kind of stuff. So what I did is I opted to replace some of these with 220s, and then I put like 2 100s and then a 220, and these are all in parallel, and that would be for like the negative side, and then the same for the positive side. So I just upsized one of the 6 capacitors to a 220. I don't think it's going to make much difference. Went through and I tested all these transistors. This top portion, this is all left channel. This is where we're not getting our signal through. This is dead here somehow. So I went and tested all these transistors, and they're all fine. I didn't get to test any of the FETs. And I was testing some of these caps too, because especially these styrene caps. These styrene caps are heat sensitive. And that's why they're mounted up on their wires like this. They're mounted off the board so they don't get any damage when they're soldered in place. That's why they put them up on little standoffs. Heat sensitive caps, I tested all those. They seem fine. What I'm going to do is once the amplifier is all finished and back together, I'll troubleshoot this better, and I'll have a better sense of what's going on. This will be easier to troubleshoot when it's inside the cabinet, powered up, and then I can trace a signal through it. Could be a bad switch, I don't know yet. I highly doubt it. Those switches seem clean when I was manipulating them. Yeah, so I think it's pretty much good now. Clean the back of the board. It looks a lot better than when it came in, that's for sure. And added heatsink compound to these 4 transistors because they didn't have anything, just to help it out a bit. Here's a look at the speaker output connector. These are not standard to this amplifier. I don't know where they got these from. But look at this. Somebody got really aggressive with the sandpaper or something. And the soldering is not the greatest, I'm going to tell you right now. So I'm going to clean this up a bit. Wow. Here's the power amplifier. There's only 2 capacitors here on the one side. I don't know what size they are. 100 volts. 4.7 microfarad. No, 47 microfarad, 100 volts. I don't know what they're doing with those 2 caps. And our relays. I'll pull these out. I don't think anybody's ever touched these relays before, judging from the... No, it's got factory soldering on the back. So, have a look at this. How somebody's gone through the effort of carving out all these traces. I don't know if you can see this. They went through with... I don't know what they were doing. Somebody had an OCD over having a solder bridge and went to town on this board, carved out every spot that they thought they were, like right here, where they thought it was too close. I don't think they would do this at the factory. No, this isn't factory because it was wave soldered, and all these bare copper spots would have solder on them if that was the case. Some butchery going on here. There's a component missing here. What is that? C C434. Can you see that? It's like a capacitor missing. I don't know. Really weird. And then somebody had these power devices out because there's lots of rosin flux here that they never cleaned up. So I don't know if they blew up this side. Let's see, 2SA 1094, 2SA 1095. So these are different transistors from one side to the other. 2SC 2564, 2SC 2565. Yeah, so I think they blew up this side and they replaced all the silicon on this side. I see some cracks here. There's a crack here. I don't know what this is for. It looks really rough. I'm going to have to clean this up to inspect it because the flux is... This resistor has been replaced. Yeah, somebody blew this amp up once upon a time. Yeah, I'm going to go full disassembly on this. I'm seeing a lot of things that I'm not liking. There's cracked solders. They have these, call them rails. Let me flip this over and show you. They have these metal bars that run along the length of the board. There's 3 of them here. And I think what they're doing is they're running positive negative rails on these. They have it on both sides. You can see it there too. And down underneath I'm seeing cracks on these rails. And yeah, this is not cool. Cracks anywhere in a power amplifier is not cool. So I'm going to take this fully apart, clean the board so I can get a good look at everything. There's some other cracks in here too on some of these transistors. Like for example, X423 has cracks on it. Somebody's been in here doing some soldering though, and yeah, I'm gonna clean this all up. This is a mess. Have a look at this driver transistor here. It's got 2 insulating sheets on it. I don't know why they put 2 on here. Maybe one wasn't good enough, but I don't even think they have any compound on here, no paste. Come on. Look at that. It's all dry. 2 insulators. Like what's going on with this? Who did this? There it is, it's all apart now. You can see. And you can see how filthy this thing is. Let's take this all apart and clean it. Cleaning is the main thing why I want to take it apart, but also there's a lot of problems on this board that I spotted. Mostly cracked solders. And I'm going to clean up a lot of this. All these wires. I don't know why they have them so long and they're hanging. Shorten them up and let them lay flat on the board. It's nice, tidy. So I'll get busy on this. Somebody has done a lot of work to this. I'll remove these transistors and record their location first, and then I can scrub everything. Remove the relays, work this board over. Gotta test all these resistors. These white ones. These like 1 watt 10 ohms. 1 watt 10 ohms. This is 820 ohms. Make sure they're all on spec. But this worked really well. I did listen to it, and it was working. So I don't expect to find anything wrong with it, other than you know, maybe these caps need refreshing. So these are the only 2 caps on the. I think these are sitting on the power rails, positive and negative power rails for this amplifier. And that's the only. Yeah, it's the only filtering they have. 47 microfarad. I think that's kind of inadequate, but who am I to know? Okay, I'll get busy here, remove the relays and get started. So I'm just going through the power supply right now, and have these caps out, tested them. They test fine. They're going to go back in. For whatever odd reason, these are 80 volts at 820 microfarad. I have a pair of these, and then they have a pair of these are 71 volts at 4700. And then they have, well, the resistor or capacitor banks. I mean, you can't see it. They have this bank here with the 820s and the 4700s, and then they have another bank here with all 4700s, and these are paralleled. They have two caps in parallel with each other, and they have your positive and negative supply. So they're targeting about 15,000 microfarad overall with all these caps, and they're all holding up, so I'm going to leave them. But just looking at this power switch here, it doesn't sound right. It doesn't latch properly. And let's shut that off, and I'll test it right now. Here is beeping, and the switch is open or off. Yeah, this switch is buggered. So I'll just replace it with a brand new switch. Oops. I'll just replace it with a brand new switch. This is what I'm replacing it with. That's adequate. Same footprint, same plunger. So it should be okay. Now I don't need to add a capacitor here because there is one back here on this board. As the leads that go back, there's a cap here. So I'll put this new switch on, and then we'll be done. Alright, so power supplies all put back together and reinstalled. The caps are back in. Everything's connected. Got a brand new power switch installed. Next is this board here, which is, I believe, is the tone board. It has its own power supply. Just like the Phono stage, it has its own power supply, so I expect some of these caps will be dead. Pull this out. I don't know if I can remove this board without taking half the chassis with it. So I might just flip the chassis up on its end and disconnect the board from the frame, and then I can work on it. I can actually work on it connected to the frame. I don't need to remove it. I have access to both sides of the board, so I'll just flip it up and work on it that way. Okay, take out two screws and this side panel comes off, and it gives you access to the mechanism here. You can see how it works. There is a little copper beryllium spring here, and it goes against this piece of plastic. There's two things at play here. Either the spring's got weak, or this plastic looks like it's kind of collapsed in just from the pressure over the time. But it barely touches the spring. I think I can just loosen this screw here and reposition the spring a little bit. Let me see. See how much that I can move that. Can't move it at all. Okay, I'm going to tighten this down. Let's see how that works. No different, no different. Okay, next step, I can bend the spring out a little, like that much. That might be enough. Let me see if it holds. No, it doesn't. I'll show you. Doesn't hold. I'm scared that this piece could break and collapse in on itself. I'm gonna try bending this a little more. I really don't have any. Let me try that. It's not good enough. I'm gonna have to do something here. Alright, here's a look from behind. That's why I said I think the plastic's is collapsing in on itself. See it? The plastic is not being very... What I might have to do is fill in behind here with some... I'll cut a piece of plastic or something, fill in behind here and glue it in place. just to keep this from collapsing in, and if it keeps it pushed out, then it'll stand a better chance of holding when it's closed. The only other alternative would be a spring of some kind to pull it closed. Just wondering how I could rig up a spring on this eyelet here. Okay, let me think about this. Okay, so I found a piece of plastic to stuff in there, and I'm just going to glue it in place with some UV cure resin. And that should hold it, and that should prevent the plastic piece from caving in on itself. So let's shut that off. Let's try this. Alright, so this can go on like this. And then we need to put this back together. Okay, I think this is going to work. Let's try it. Let's try this. Oh yeah, it's got a lot more strength. It doesn't fall open on its own. I think I'm going to leave that alone. The only other option I had would be to mount a magnet up here and put a little magnetic plate and have it a magnetic latch. But I think this will work better. It stays closed on its own, so that's what I wanted. Alright, I removed all the lamps from the front panel just so I can service them, and we got 12 lamps here. Yeah, some of these are burned out, this one's broken. I think when I was manipulating it, I think I snapped the wire. Oh well. But I was trying to get a read on what kind of lamps these are. There's no mention of the lamps in the service manual. I spent 15 minutes yesterday combing through it. Couldn't find any reference to a part number. Well, basically what I'm trying to figure out is what the voltage of these bulbs and what their current rating is. That's important, because they have some weird circuit, and they even spell it out in the service manual. In the troubleshooting section, they have indicators here. You want to pause and read it if you can. But they really don't tell you anything here. They just say if one lamp's burnt out, then it can affect all of the lamps. Fair enough. They have some weird current limiting circuit, and I think it's a constant current that goes through the indicator lamps, but you can switch lamps in and out. They have capacitors in there too. I don't understand what they're doing. I didn't take the time to sit down and figure out the circuit, and to be honest, I really don't care. I just want it to work. So what I'm going to do is I'm probably going to replace the burned out bulbs with the same kind, but like I said, I need to figure out what voltage we have and what current. So if I have 6.3 volts here on the power supply, let's try this real quick. Let's see if I can get this to work. See, this solder joint is broken on this one. So let me put this here. Let's see if I can get this. And 6.3 volts, we're getting about 70 milliamps. I think that's correct. I don't know. Let me try in the darkness here. See if this is bright enough. It's got to shine through the front. I think that's bright enough. So we're going to go with 6.3 volts, 70 milliamps for bulbs. And what I'm going to do is I'm going to test some of these for, see which ones are alive or dead. Let's do this quick. Good, good. No good. Good. So this one here is no good. No, all these bulbs are good. Doesn't explain why they're not working though. This one's good. That one's open. Good. That one's broken. Good. So I'm going to get some new lamps in this. Probably, I think there's two here. One's broken for sure, and one's burned out. This one's got a bad connection. I think there's one burned out one and one broken wire. So I'll get some lamps, and we'll see if we can get all these lamps working. Also, if you ever run across one of these amps and you have problems with the main amplifier itself, this one's working, so I don't have to do any troubleshooting. But it's quite a complicated amplifier. It has, for the block diagram here, it has a driver amp, impedance conversion, bias control, power limiters. I don't understand what they're doing here. I didn't read through this. And then they have their power amp stages onto the load, and then negative feedback going back to the beginning. So they have a global negative feedback. Yeah, it's quite involved, and the troubleshooting procedures for this are quite involved too. They have a lot of steps to go through, tests, and if you read through all of it, there's a lot of stuff here going on. There's a lot of a big write-up, and this will help you if you need to do any troubleshooting, preparing the power amplifier stage with the check. Even tells you right at the top here, troubleshooting and servicing for damaged power transistors is the most difficult with this unit. These are explained here. Servicing with consideration paid for separation of the stages. So you got to remember these are separate stages. Standard simplified servicing methods must be avoided when repairing a super A amp, turning on the power immediately after replacing power transistors because they have damaged or replaced parts to the right channel. This method is employed, must be avoided because you're going to end up blowing up the system again. Alright, got it relamped. So I replaced 3 lamps. These 3 here. These are 6.3 volts, 75 milliamps, just like the other ones. A little different, smaller size, but that doesn't matter. Now, I didn't find any burned out lamps. All of these lamps work. One of these has a broken wire, and 2 of them have reduced current. If I put 6.3 volts on them, they only have about 40 milliamps, not 75. So those are gone, and they're all equal now. And this I can put back in. The main thing was the soldering on the back of some of these lamps was terrible. I think some of the connections were broken, but somebody didn't. I don't know what was going on, but the solder they used wasn't correct, and it just didn't stick to the wire, so it wasn't working. So I redid it, cleaned off all the old solder and resoldered them, and put this back in and see how it works. Doesn't hurt to take the cover off to check the volt setting here. And we are already set up for 120, which is good. Don't need to change anything, so I'm going to put this back. Okay, we're doing the first initial power up. Everything's going well. Our power consumption is 48, 49 watts. And I just set the DC balance for the amplifiers. That's on the preamp board here underneath. There's 2 adjustments, and you can do it at the speaker terminals if your relay's turned on. If not, you can connect to there is a jumper or a connector for left and right channel for doing bias adjustments, and we can pick it off. You can pick the signal off there too. But everything's good. It's right at 0, and it's hovering right at the 0 mark. Nothing's changing. We do have a problem though. We don't have any lamps. None of the lamps are working, and I still haven't confirmed if the phono stage come back to life yet or not. We have to troubleshoot that if it's not working. So just trying to get the bias set on this. The instructions are quite confusing. I'll tell you to main amp idling current, left channel you measure at pins 17, 18, 20, 21, and test point 19. I don't understand why they have so many test points, and which ones do we measure between, because they're asking for 40 millivolts to 60 millivolts. But which pins? I don't know. I don't understand this. About 10 minutes after power turn on the heatsink. Yeah, okay, well I'm going to fumble through this. We'll get the bias set somehow. It's been on for about 15 minutes. It's doing all right. Okay, it looks a little more clearer on the schematic. So we have test points 6 and 9 here for these two emitter resistors, measuring outside to outside. And then we have 5 and I think that's 8 for these two. 7 is the output of the amplifier, and test point 4 is ground. For the other channel we have 20 and 17, and then we have 21 and 18. 19 is our output, 22 is our ground. Okay, I think I figured it out. They want you to measure, there's 4 test points, 17, 18, 20, and 21. And those are the 4 emitter resistors. And they want you to measure it between those 4 points and the center test point, which would be 19. 19 is your speaker out line. So they're asking for 40 to 60 millivolts on each of those resistors. Those are half ohm resistors, or 0.47. So that's a fair bit of current. So right now I'm measuring across both, and I got 60 millivolts here, and I'm monitoring this. I don't know if I'll go up that high. I'm going to go up as high as I dare, but our power consumption has gone up too. Since I turned it up, our power consumption is going up and up and up. So this would be a bit of a power hog, this amplifier. But I'm going to go through and do one channel here first, and then I'll do the other channel. I'm going to let it heat up and stabilize, and then I'll get the bias just right on this amp, and then we can go on to testing. Okay, first anomaly I discovered. This is not right. I had my probes attached to the 2 red terminals, assuming that was the positives, and then I had my ground. I had a ground attached, floating ground to the chassis, not to these. And I assumed the reds are positive, the black's negative, and I couldn't get anything on my scope. Nothing at all. So then I decided to connect the ground from the scope to this, and I got a spark. I said, what the hell's going on here? These are reversed, so these 2 outside ones should be red, these 2 inside ones should be black. Change that around, now it's working. But, you know, wow, somebody who replaced those couldn't even get it right. Alright, here's a look, feeding a signal into the phono stage, and we still have a dead channel. So that is the right channel working, left channel's dead. And if I play with the switches, this is moving magnet, moving coil. This is Phono 1, Phono 2. So there's no signal at all on the one channel. I'll try this. Yeah. Alright, so I got some troubleshooting to do on this amplifier card. I'm going to have to trace a signal through if I can. Yeah, that's what I'll do. I'll just trace a signal through. I'm going to get the schematic out and see where I can pick off some test points. That's it right here. Pretty simple. Left channel. I think the left channel is the top. The odd numbers is left. And then I can follow the signal through, see if I got, figure out why we got no left channel here. Okay, I'm just trying to figure this mystery out here. This is the phono equalization card. Everything on top here is the left channel. This side here is all power supply on this side. And this here is the output. These, oh, you can't see, it's underneath this cap. There's a connector here that I just unplugged. Pin 10, 11, and 12. Pin 10 is the right channel, 11 is the ground, and pin 12 is the left. So I measure on pin 10, I get 0 volts. Ground is 0 volts, obviously. Pin 12, I get 12.5 volts DC offset. Now this is a DC amplifier, so there shouldn't be any DC being outputted by this stage. So I'm going to try and figure out why do we have a 12 volt DC offset on the output of this. These are the two output devices here. And I'm going back. Voltages are all whacked. Now I'm suspecting something maybe with one of these JFET pairs. I'm not sure. But I'm also checking back here on, I can't see, I'm not pointing in the wrong spot. There's an op amp back here, and I check voltages around this op amp, and things don't add up either. So I think my first step is I'm going to pull this op amp and test it, and see if this is maybe the cause of the problem. One side seems to be working, the other side doesn't. It doesn't seem to match the voltages that it should be there. On the inputs I got two positive voltages that are equal, and on the output I got a negative voltage. Let's see here, on the other side, on the input, I have negative half a volt on one input, and I got 9 volts on the other input, and on the output I got 12.3 volts, which seems correct. Yeah, so I'm going to pull this, going to have a good look at it, because if voltages are equal on both inputs, the output should be 0 and not negative 3.3 volts. So I'm going to pull that and take it out and have a good look at it. Okay, I've been struggling with this for a while. I did a lot of things. I yanked out all these transistors and tested them on a circuit. They were all fine, including these FETs. These FETs here, and I actually replaced this op amp because I tested it tested fine, but then it gave me some indication that it might have been intermittent, so I replaced it anyway. But no change in the functioning of the circuit. It didn't get our left channel back until I started checking voltages. I went through around here checking. This line here is the output line for this amplifier, and it had 12.5 volts on it, which was way out of whack. It should be 0 volts like this one. And then I started checking voltages around these transistors here. I was getting negative 45 volts on one side and plus 45 volts on the other side, and no voltage drop across any of this string. This string here, between plus minus 45, you should have 90 volts potential difference. And I checked R151, it's a 220 ohm resistor. Check the voltage across there because I want to know how much current this string is drawing, and I checked the voltage drop across this resistor and it's 0. So that tells me none of these transistors are turned on and there is no current flowing through this string. So I start investigating. All these transistors were fine. I checked R153, it's fine. Everything checks out fine. And I said, why isn't this string getting turned on? So then I started checking this biasing string here. This one here, just in front of the transistors. And I was checking on top here. I got, I think it was, let's see here, negative voltage on one end, positive voltage on the other end. And I come up to R145. It's a 91K resistor. And I had plus 45 volts on one side of it, negative 45 volts on the other side of it. So that's the 90 volt potential difference across a 91K resistor. If we do the math, I equals E over R, so E is 90 divided by 91,000. And we should have about 900 microamps of current on that resistor. So I pulled that resistor out, and I'll show you what it tests. So here's the resistor connected, and that's what it shows. It's open. So I'll pop a new resistor in there, and this should bring this back to life, the phono stage anyway. We still have to sort out the lamp circuit. Alright, got everything connected. Let's power on. Wait for the relay click. There it goes. Okay, turning it up. And we have signal on both channels now. Perfect. So our phono stage is now working. Excellent. Okay, quite puzzling. I don't have any light function at all. Went through and replaced all the, well, I replaced 3 bulbs. I think none of the bulbs were actually burned out. That's what confuses me. Somebody's been in here replacing bulbs, and you can tell by the solder connections on the bulbs themselves. Some of them were pretty poor, and one bulb didn't have the solder stick to the leg of the bulb, and was open circuit. But that's the only problems I found. So I went through, removed all the bulbs. I tested all the bulbs for current draw, and they're all about 75 milliamps at 6.3 volts. Now I don't even know if that's the correct voltage and current for this application. I couldn't find any mention of what bulb they're using in this manual. But here's a clue right here. It says 14.6 volts and 14.6 volts on these two transistors. I happen to think these two transistors here are current regulators because they take something like 49-50 volts on the emitter, and then on the collector we have 14.6 volts. Now, is that the correct voltage for the bulbs? I don't know. So what happens here is all these bulbs are wired in series, these ones too, and as you switch your switch in and out, it either bypasses the bulb or puts it in circuit, which allows it to light up. And it's really confusing here because they have capacitors in the way too. They have these capacitors. There's 6 or 7 of them. 470 microfarad at 6.3 volts. Not quite sure what they're doing with these caps, but nothing's working here. So that's what I'm trying to figure out. Is it this, or is it this here that signals these two bases to turn on? This line here that goes to this is the bias and protection board in the middle of the amplifier. I'm going to pull this board out and check all of this circuit here just to make sure it's working, because I measured here and I have 6.3 volts on one of these. I can't remember if it's both or one, and that should light up the lamps, but nothing's lighting up. Now I also checked for grounds. Grounds come out, where is it? This, no, that's not the ground. The ground is on the other side. This is ground here, and this string is attached to ground, and this string is attached to ground at pin 20, and I do have a ground connection. I checked that. So I'm going to go through and figure out what's going on here. If I don't have enough base turn on here, I'm going to figure that one out. Okay, update. So all the lamps are working. I don't know if you can see them here. They are lit up. We've got 3 lamps lit. Now if I turn that one on and off, maybe you can't see that. Let me put some black background behind it. Maybe you can see it better now. I don't know. But the lights are so bloody dim, they just don't have any, like I could measure a voltage across one of these bulbs. Let's do that right now. I think, I don't know what to think about this. I don't know why they tried devising this fancy lamp system. Let's see what I got across this bulb. 1.8 volts, that's why it's so bloody dim. Alright, so as far as I can tell, everything's working. These two transistors are working as current sources. They're a constant current source. And they supply 2 strings of lamps. One is this lamp here, power, speaker, subsonic tone. And then this other string is over here. This one has muting, record, tape monitor, auxiliary, moving magnet, moving coil. So these 2 strings of lamps run off here, and it's working because I can push the buttons, the lamp comes on. Problem is, it's so dim. Now, I made an assumption when I opened this thing up that all the lamps were original, but I'm wrong. Somebody was in here monkeying around replacing lamps. They took the original lamps out, which I happen to think are about 35 milliamp lamps, and they put in some 75 milliamp lamps. So they're a little more stout, a little lower on resistance, which means the voltage drop across them is going to have to be higher before the lamp lights up full brightness. with 34 milliamps on a 75 milliamp lamp, you're only going to get about half brightness or quarter brightness. I went on Audio Karma. There was a thread on there about the same amplifier and the troubles that the guy was having getting this to light the lamps. He was trying to do an LED retrofit, and it wasn't working because the current was blowing out his LEDs, and it just wasn't working. But they talked about changing a value of a resistor. They talked about changing the value of these two resistors, R481 and 482. Currently they're 150 ohms. I think they're 1 watt. I'm not sure if I can see one here. No, they're 1 watt. I'm thinking of lowering these resistors to a different value, maybe 100 ohms, I'm not sure yet, to increase the current. And then this all should work. It should all start working. So what I need to do now is measure the current across one of these resistors right now to see. Let me turn things on and let me get a voltmeter. We got lamps on this side, lamps on that side. Let's turn some more lamps on. Okay, whatever. We got lamps lit. So let's go across resistor 481. R481. Let's see what we got for a voltage drop across this resistor. I don't know if you can see it here. 5.3 volts. 5.4, let's say. Okay, shut this off. And that should be 150 ohms. Let me check it again. $147 ohms. And we go I equals E 5.4 divided by 150, 36 milliamps. That's exactly what I thought. So we need to increase this to 75 milliamps. So what I propose to do is change this from a 150. Let's see, I want to double the current. So to double the current, let's see, what is 75? 36 times 2 equals 72. Yeah, I want to double the current. So I'm probably going to have to put about a 75 ohm resistor in here. And let's plug this in. Turn power on. Got nice bright lamps. Constant current. The constant current keeps the current through the other lamps constant, so the brightness doesn't change when I switch lamps in and out. That's why they did this. Now, this is looking really good. Okay, I'm going to put this all back together, and we'll finish this up. Alright, I think we're ready to do power test. Let's plug this baby in and see. What we can do. Alright. Signal set up, scope is going. Let's turn this thing on. And we should have signal on both channels. And we don't. Why do we only got one channel? I got a broken wire on my volume pot, and that's from all the removal and putting the faceplate back on, and so I got to resolder that. So give me a second. Take 2. Alright, so I got everything connected. I did have a broken wire on the volume pot, which I had to shut down production and resolder that. It was from all the disconnecting, reconnecting, wire broke. It's common. So let's turn this thing on after we plug it in. I haven't tweaked the bias yet because it still climbs up quite a bit on its own. I'm gonna monitor that. I think I'm gonna go maybe do some changes. I don't know yet. I haven't decided. Let's get this out of the way first. So power on. here we have times 10 on our probes. Okay, so let's see where our clipping is. Right there. Alright, let's try that again. There's clipping. Looks like we got some sticking going on the transistors. When they clip, they stick like that. So let's say right there is our peak, and we have 32 volts even. Wow. Let's start our timer, and I'll bring you back in 10 minutes or sooner. Here's what we got going in, 241 watts. Okay, I think we have a problem here. We only have one amplifier doing any work. This side's cold, this side's hot. We have 32 volts RMS going out on both speaker connections. I think one of my resistor loads is open. That's why, because if I look at this doesn't add up. I have 100 and some odd watts going out the back. This would be a lot higher. So I think I have an open resistor. Maybe the last time I did that power amplifier, I burned one of these out. So let me shut everything down and do a check this here. Just turn this down, turn the speaker off, and let's just check what the resistance is on those loads. I thought something was funny. All right. Yeah. Okay, that resistor's 9 ohms, and this one here is open. Yeah. So I have to redo my test here. Just give me a minute. I gotta get my resistive load fixed, and then I'll bring you back in. All right, ready for round 2. I replaced a dead resistor. These are rated at 100 watts if you heat sink them properly. But I don't think they're rated for 250 watts, so that's why that died, I think. Let's continue on. Okay, I got this. Let's turn this on. How come I got no... Turn the speakers on first. Alright. Okay, let's take this up to clipping again. Let's go with, where are we here? Right there. 30.1 volts RMS. And that's with both channels driven this time. 415 watts going in. And let's get our timer. Start this, and I'll bring you back in 10 minutes. Alright, I'm at the 10-minute mark here. I think this is doing really well. We don't even have 50 degrees on our heat sinks yet. 51 in this back corner. 48. 45. Yeah, this is... I'm going to shut this down. Turn the fan off. Turn this down, and I think that was a success. So Once we sorted out all the little problems with our testing, we finally got it to work. So let's turn this down. Let's do this and this. Let's turn this down and let's go to square waves. All right. That's 1 watt right there. So, looks pretty good. At 1 kilohertz. I think the tone controls are turned off right now. Let's turn the tone controls on. And let's manipulate the bass cut. Bass boost. Okay, it's working normal. Treble cut. Oh, that pot is still scratchy. And I did clean it. Might have to go back in and redo this pot. But subsonic. And that is it for filters. Balance control left and right. Okay. Muting. Takes it down 20 dB. Tone controls off. Alright. Let's see how low this thing can go. Hertz. $30, $20, $10. I think the right channel is doing really well, but the left is struggling with some low frequency roll off there. I wonder why it would do that. That's 10 Hertz. Let's go lower. 9, 8, 7, 6, 5, 4. You can see the difference between the two. I wonder if this subsonic tone controls. Interesting, this amplifier doesn't have a loudness button. If it does, I don't see it. That's 4 Hertz. 5, 6, 7, 8. I wonder why it's doing that. Interesting. Okay, let's go to the high end. That's 1 kilohertz again. $10 kilohertz. Looks pretty good. This is at about 1 watt. So right about here we lose it. 55 kilohertz. Not bad. Pretty good for this old girl, considering it's from the 70s. Alright, here's a look at the parts that went into this. So let's have a look at this side here. This here is power switch it's still shorted. I just replaced it. I could have used this side, but opening one of these up, I'd have to drill these rivets out, take the lid off, and it might not even be fixable, and then I'd have to figure out a way to close it back up again and hold it secure. So it's just easier just to replace it. So that's gone. Let's look at this here. We have 3 lamps I took out. Now these 3 lamps I took out because, not because they're burned out. One of them I broke the wire on them. These were actually reading at 35 milliamps. Now these are probably the original lamps that were in the unit, and then somebody come along and replaced them with the 75 milliamp bulbs. Now I didn't find any burned out bulbs. All I had was the one with the broken leg, and then I did that. But the lamps weren't working because they had the wrong lamps in and the wrong current. So I'll talk a bit about that in a minute here. But yeah, relamped with that. This resistor's out of tolerance. This is a 820 ohm, and it measures down around 600 ohms. So I got rid of that. A couple of resistors here. This is the 91K resistor that was open on the Phono stage, which shut down the left channel completely. So that's been replaced. These 2 resistors, I just replaced them just because they got covered in conductive glue and they looked like they were starting to corrode, so I just got rid of them. And that's it. Now these 2 resistors, I removed these to adjust the current for the lamp circuits, and I replaced them with an 82 ohm. This is 150 ohms, so these are still good resistors. I just changed them. These capacitors, and these capacitors, I separated them in 2 different piles because of one reason. Some of these caps are totally dead and failed, and some of them are still working. So the ones that are still working are these ones. These ones have all failed, completely dead. Some of these measure out in picofarads, nanofarads. Most of them are down, like these ones, they're down quite a bit. They're down to like less than half, or they're maybe 1/10 of what they used to be in value. So that these all failed, and I'm really impressed on how well this amp sounded with all these dead caps in it. It chugged along and it sounded great, and I think that's a testament to having DC coupled circuits with no interstage capacitors. These are all power supply, and the blue ones here are the lamp circuits. There's a couple in here that might be a coupling cap. I don't think I saw one coupling cap in this whole thing. Yeah, these are all done. Power supplies all had failed caps in them, and considering how bad they were, it still sounded great. These ones were okay. These are all power supplies too, but these were still functioning. Okay, let's talk about this lamp circuit in this amplifier. They even have a little write-up in the service manual about it, but you know what? They really failed when they wrote that little article, that little this indicator here. They could have made this clear. They could have said, you know what? We got 2 constant current sources, and they provide X amount of milliamps for the lamps, and the switch lamps in and out on the circuit. The current stays the same, but the voltage changes as you add and delete lamps, and that's how they're doing it. But no, they put this in here, and it doesn't make any sense. All it does is it says it's complicated. So they weren't really clear on that. They could have made it a lot clearer. They also could have made it clear in the service manual what these lamps are supposed to be. They'd have no voltage or current rating for any of these lamps, and I looked through the whole thing and I couldn't find it. And but what you need if you have problems with your lamps is you have to go through and replace any of the burned out lamps. These are all one in series string, so we have a series string here and a series string here. 5 and 6 lamps. No, it's 7 lamps. 7 and 5. But if you're going to replace lamps, they have to be the same voltage and current. Okay? All the lamps in the string have to be identical. You can't just go in and replace one lamp with a different current lamp and expect it all to work, because it won't. Even though it's the same voltage, you have different currents for each bulbs, different bulbs. So the way it's configured right now, they have the two current regulators here, and they are preceded by two resistors, and they're 150 ohms at half watt. And that current configuration sets this current regulator up for 35 milliamps for each string. So these lamps need to be 35 milliamps, and that's what they are when they came from the factory. So what happened in this case, somebody went into this amplifier and replaced a bunch of the lamps. They left two of the original 35 milliamp bulbs, and then they replaced the rest with 75 milliamps, and then they turned it on, nothing worked. And I came along after and took out those two 35 milliamps and replaced them with 75s. Had all these lamps were working, and all these lamps were good. I checked them, and the lamp system wouldn't work. But then I realized it's not being fed with enough current. So this current wasn't enough for 75 milliamps. This is only delivering 35, right? So what I did is I lowered the value of this resistor from a 150 down to an 82 ohms, and that increased the current. This zener here, this 5.6 volt zener, this sets up this. This is always going to be at 5.6 volts at the base of these two transistors, which puts the voltage drop across these resistors always at 5.4 volts. So if we want, we can do the math, and we can see with a 150 ohm resistor, we're always going to get an X amount of current. So 5.4 E equals I over R, so we got 5.4 divided by 150 equals 36 milliamps. Okay. Now if you want to change this up or change it down in value to accommodate what you're putting in here, if you want to put LEDs and run these LEDs at a very low current, let's say for example 3 milliamps, what you would do is R equals E over I, so it'd be 5.4 divided by 0.003, and our resistor would need to be 1800 ohms, and that would limit the current on these strings to 3 milliamps. Then you could switch in LEDs. The voltage doesn't matter because the voltage will change as you switch in and out LEDs, as long as the current stays the same, right? Now you could also put incandescent lamps in here. I would suggest 6.3 volts or 8 volts. I think 8 volts would work. Let's see. I think we have 1, 2, 3, 4, 5, 6, 7 lamps. 7 times 8 equals 56 volts. See that? That won't work because, well, actually, you know what? That will work because this lamp or this lamp is going to be on, not both. So this circuit here supplies close to 50 volts, and we're asking it to deliver 56, but minus 8 equals. So we need 48 volts for this all to work, and we have over 50 volts here. So this will work on 8 volt lamps as long as the current is correct. But I would stick with 6.3 volts for these if you're looking for lamps. 6.3 volts at 35 milliamps. Then you don't have to make any changes to the current. You just put your new lamps in and it should work. Okay, I'm going to end this one here. I'm finished with it. I'm going to move on to listening to it now. I really enjoyed listening to it before I started, and I think it's going to sound just as good after. I remember doing the AX9, and I really enjoyed listening to that amp after I finished. It was a great sounding amp, and I know this one's going to be a good one too. It does have its issues though. Like it is a power hog. I think the Super A here, I'm not exactly sure what that means, but I think they're trying to run some of the circuits in Class A mode, which creates a lot of heat. And this thing is a power hog, but it's going to sound good because of it. And I think a lot of this problem with this thing is it doesn't stay completely closed, but it is holding up. So I'm going to end this one here. Thanks for watching, and we'll see you on the next one. Take care.